of the actual contents of this talk. The talk is called The Dirty Empiric Science. It's unfortunately not a perfect method, but still the best method that we've found so far. And if I say there's still beer in the fridge, then you can believe me. But if you actually look into the fridge, then that's science, because with science, you basically test hypotheses and see if these hypotheses are actually true. Okay, sounds good, but where's the problem? But psychology can cause some problems with that approach, because there are a lot of studies that show that there is a certain effect, but if people try to replicate these studies, they get a different result. So we actually can't try to trust the studies that are being released. However, in this talk, we will hopefully learn how you can figure out if you can actually trust a certain study or not. And please give a warm round of applause for our speaker. Good morning, everyone. Welcome to this talk. I hoped I would first talk about what I can't do, which is drawing. And no, that's a joke. But I would rather talk about my motivation, why I want to give this talk. And I hope you can read what's written on the slides. And now I will read what is written in the bubble. Wow, so many people here. I'm dizzy. And if I fall over, I'm sure there will be no one who will help me. And then another person says, why? Why do you think that? Do you know the bystander effect? If there are a lot of people, then no one helps. I've read this in a study that proved this. This can't be. I was at the Congress and someone already helped me. Well, that can't be true. The study of Borgs and Pentra has found out that people in groups do help as much as people who are not in groups. Well, as the saying goes, don't trust any statistics that you haven't forged yourself. And we want to talk about how empirical studies actually works and how what constitutes studies and what makes a study a good study, and how you deal with different results. And in the end, we want to talk about what kind of problems there are in science in general. First of all, about me. I'm Anna Klingauf. I'm a psychologist. I work at the University of Kassel in the section of human-machine interactions or systems techniques. So we do a lot with technology and the interface with humans. And to keep this entertaining, I'm showing you a study where we can basically go through everything by example. And this is about facial feedback. And the hypothesis is that it's not only our faces and our facial gestures that influence our emotions, but it's also the other way around. And here we want to state that smiling increases the positive attitude, and if you don't smile, then this decreases the positive attitude. And when the study was released, there was first one approach that said, this is all based on cognition, this is on self-awareness. When I'm looking at myself, when I smile, then I conclude that I'm happy. And this makes me more happy. And there's another approach that is psychological. And they say that the muscles that make you smile are connected with the emotions. And now the question is, how do you figure out which one of these two approaches or explanations is actually the right one? And And there's a study that investigated this, where they tried to figure out which one of these two hypotheses or which of these two approaches or explanations is actually true. And as I said previously, trust is something different than understanding. If I say, yes, you can trust empirical studies, but then we don't win anything. But if we actually understand the studies, then we have a better estimation and better understanding of if we should trust these studies. And to clarify, I only want to focus on quantitative research here, and that means testing a hypothesis that we already have. But there's also other approaches like qualitative research, where people first develop hypotheses. So what do we need to do empirical research? First of all, we need a hypothesis. For instance, smiling increases positive emotions. And how does the experiment work, or how could an experiment work? So, first of all, we have to find some study participants, and we have to manipulate them. That sounds bad, but it's not bad. It's just a regular term that we make sure that people do what they need to do for the study. And in this case, it's smiling or not smiling. And then we have to measure the effect of the manipulation. And don't worry, there are no formulas in the slides. And in the end, of course, you have to use statistics to compare study populations. And in the ideal world, we would, of course, test all people. So we would need to take everyone on this planet to make our test. Of course, this is not realistic, and that's why we need to have a huge sample from the population that should ideally be representative of the entire human population. And the sample should really be representative of everyone we're interested in. So you should have young people, old people, men and women. And this is not always realistic or not always feasible to achieve. And that's why you basically have to assess yourself if it's still reasonable to perform the study if you don't have ideal study populations. And I have to make some assumptions if this study would still work with an unideal study population. And it's also important to consider that we're doing a random sample. So if I have 100,000 people and I only pick 10, then there is a certain influence by this random pick. And it depends on where within the population or where within the distribution I sample people for my study, I will get different results. And in this study, we had 92 students that participated. And here we wanted to investigate the effect if smiling is really causal for the effect. And it's really important that everything else is the same, because if there's anything else that is different between the groups, then these differences could be causal for whatever we observe. And it's also important that you don't directly instruct people to smile, because this could influence people to think about their actions, but we would rather have them do it implicitly or intuitively, so that study participants don't fully understand why they're doing certain things. And of course, how do you trick people. And one way is to say, okay, let people just have a pencil in their mouth. And so for those in the audience, if you want to participate, you can take a pencil between your teeth, and then you can try to move the corners of your mouth. And if you take the pencil through your lips, then you will notice that your muscles will be affected.
And you can't smile anymore. And this is a way to get them to get the people to smile or not smile without telling them.
Manipulation jetzt rauskriegen kann, welche der beiden Theorien trifft eigentlich zu.
And the good thing is that with this manipulation, we can sort of find out which of the two theories works, because cognitive theory can't be used here, because when you think of why am I smiling right now, your idea would be not because I'm happy, but because I have this pen in my mouth. So if people still are more happy if they have this smiling muscle contraction, then it's definitely the muscles that are related to their mood. So now we have to measure. So one thing that's very important here in psychology that is always problematic, because most of the things we want to measure, you can't measure them directly. You can't measure emotions. Different to chemistry or something like that, you can't actually measure it directly. Usually by asking them or by questioning them. And to make it comparable between two different people, there's a scale. How happy are you on a scale from 1 to 10, for example? And because our hypothesis is that emotions are heightened, we need to make them happy before. So they were able. So in this study, they watched a funny cartoon. Of course, we tested the study tested the cartoon whether it's actually funny. And one term that is often needed is operationalization. That is, I make things measurable. I make it so that I can measure things that are not measurable directly. And using this questionnaire is one way of operationalization. And important is that measuring is always inexact. Every sort of measurement that you can do, even where you think it should be exact with measuring like the length of your table, you still have a little bit of a difference. So there's always something inexact about them. And this is even more pressing when I can't measure what I actually try to measure, but instead I have to operationalize it. So this makes it more random mistakes. Now, let me summarize the mistakes so that everyone understands. So, trial subjects were invited. They should hold a pen either in their lips, between their lips, or between their teeth, or in their hands. The hand is basically the control group, which shouldn't have an influence at all. Then they should watch a cartoon, and all of them watch the same cartoon, and then they should sort of guess what is the better, or like what is my mood right now. And we had to tell them a cover story, and we told them, well, it's for the disabled people. How does writing with your mouth make or like influence your emotions? Now, methods, comparison. And this is important to me. Now, you don't have to actually be able to calculate the statistics here, but you have to be able to understand how such a statistics works. And what we want to do is compare the two groups. In particular, we want to compare how funny did they find the cartoon and how happy did it make them. And because we had more than one person, we used the average of each group. Now, can I compare this directly? Can I say, well, those that held it between the teeth had a higher average. This is how I basically confirmed my hypothesis, but this is too easy. I can't do that. Why? Because there's these random errors. First of all, those that come through measuring, and second of all, those that come through sampling, because I haven't asked everyone, but I've only asked a sample, and then I have two different random influences. And now I have two values, and I want to find out, are they different in a real way? Is it just random that they're different, or is it real? So this was the original table from the study, and mean funniness were the averages that were compared. Now we have to basically choose a statistical method, and there's a lot of different statistical methods that are useful for some users. The most well-known is the t-test, which is basically a way to compare two medians or two medians, yes. But that doesn't work because we have more than two groups. So this is why we did a variance analysis, which allows us to compare more than two groups. And this, the way of thing that we used was planned contrasts. So I can choose what kind of pattern do I expect, and then I can choose whether it works or doesn't. So I'm hoping to be able to explain it to you now a little bit. The basic question is, do the values that I have differ from each other in a real way or just randomly? So how probable is it that I'll get this pattern by chance? Now I made this graph, and you can see the three groups. They seem to be different. Now the question is it random or not? Now what I can do is I can calculate the variance. The variance is the difference between each of the values to their mean, to the group mean. And then you basically use a formula. It doesn't matter how the formula looks, but then and then you get a value. And this is what we call within group variance.
And what we do next is we do this for each group or each cluster, and then we compare the the mean values of the different groups, and then we can calculate another variance to calculate the difference between the different groups. And these two variances I can put in a relation to each other and see if the variance within one group is really huge, so that there's a great diversity within one group. And I can also say that, can state whether the differences between different groups is huge or small. So is there a huge difference between the teeth and the lips groups? And if I look at the relationships between, or the relations between these groups, I can determine by using a table or by using a statistical procedure if the observed result is by chance or is actually a meaningful result from a statistical standpoint. And the most crucial thing is that you basically compare how random does my result look. So for the planned contrast, if I had, so if I see, okay, there's an elevated level for the teeth, a lower level for the lips, that's what I would expect, and then I can compare my expectations with what is actually observed. So you want to see how likely is it that something is just by chance. And of course 100% certainty is an unrealistic objective or aim for what we're doing here. But usually we say, okay, if something is only about 5% likely or 1% likely to have occurred by chance, then we say, okay, it's really unlikely that this just happens by chance. There might be some effect. And we call this probability for saying this is just by chance, we call this P. So this is the P value. And we see that this value is so unlikely, it's like less than 5%. Then we say, okay, it is significant. And we see in this specific study, we have a p-value of 0.03. So it's 3%, and it's really unlikely that this happened just by chance. And therefore, we can be more confident in saying that there is probably a statistical connection. So what can we do with the results? So we see, okay, the test is significant. We see this is most likely not random. And we see that the difference that we observe is most likely caused by the manipulation that we have done. And because we did not because we didn't do any cognitive processing, it's more likely that the physiological theory is more likely. So the body and not the mind theory is more likely. But this is still not a proof in the sense of a mathematical proof. It's just a support for the hypothesis, because this proof can still be disproven, or this result can still be disproven by other more elaborate proofs or statistical experiments. So now, of course, we want to talk about how can you trust how can you trust empirical studies? So how does empirical study work in principle, and what makes a good what makes a good study? Okay. So what do we have to keep in mind? We have to have standardized tests so that it's all established and it has been tested by other people. And what I really appreciate is when I get an explanation why people use certain procedures to test. So when they explain why they chose specific tests, and I can really understand why certain decisions have been made. And
Was auch immer gut ist, wenn eine Studie einen Manipulation-Check durchführt.
And so something else that is also very important is, or very helpful, is when there's a manipulation check to make sure that people are actually smiling with the pencil in their mouth, if the methods that were applied actually achieved what was intended to be achieved. And it's also helpful to compare this to other studies or compare methods of other studies and see what kind of approaches they use. And something that's also very important is that you have a good samples. So usually, as a rule of thumb, you want to have like 30 people from a group, which is of course not always possible, but this is something you should strive for. And a reoccurring problem is that most studies just use students as a sample because they are more available for those studies. This can be a problem when you want to measure things like political opinions. Then students have a different political background than the general population. This is something that you really have to be aware of, and if you look into something like smiling, then this is most likely not a problem. And it's also important to see if if the experimenters have tested if the students have, or the participants have understood what the study was about, because you wanted to trick them into believing something else. And of course, you want to have a proper statistics. You need to have the right statistical procedures. For instance, if you do a lot of small tests, then this is not good because you have a greater number of false positives. Because you always say like 5% for each test, but all these 5% add up, and this is why the probability for wrongfully saying that something is significant when it is not increases. And unfortunately, it's quite difficult to understand and if the statistical procedure is the right one for a particular experiment or for a particular study. And usually what you can do still is look at what kind of things are being reported, what kind of metrics are being used. And correlations and causality, I guess most of you know this. So you have to look at what kind of conclusions are being drawn. So a correlation is just a relationship between two things, but a causality is a directional relationship where you say A modifies or influences B. And so if you, for instance, see that storks and babies co-occur, then you might conclude that there is a relationship, but if you actually do the experiments, you will see, okay, this is nonsense, of course. And it's really, really important that you look at what kind of conclusions are actually allowed to be drawn. And if there's like a temporal relationship that is exactly the other way around, then of course B can't change A.
Okay, one hint, something that you want to look at is if it's to figure out whether a study is good or not. Most studies are actually published in journals, and journals have peer reviews. And peer review means other researchers are actually kind of reviewing the research, the study that was submitted to this journal. But of course, this is not uncontroversial, because sometimes there are some researchers that kind of give better or worse results to specific people. But in general, if it's a journal that does not have peer review, that's a bad sign. Similar impact factor. It's basically, the impact factor belongs to a journal, and it basically says how often have studies from this journal been cited. This can be seen as a criterion of quality, but you really can't. But it's really important not to overstate the importance. The idea is the more well-known a journal is, the more choices it gets, because more people will submit their papers, and then it will choose better studies. But again, that doesn't mean all studies with a high, in journals with a high impact factor are great, but it's still a good hint for you. So if you found a study that you found very interesting or something, you can see an impact factor. So everything with an impact factor of 1, you can cite. What about, okay. So I tried showing you what is a good study, but now I want to ask, what do I make when I have different results? What do I do? Especially if the results are completely opposite to each other. Now, I'm going to go back to the bystander effect example. And this was in the comic, and it said, the more people are watching an accident, the less people actually help. The basis is a case of Kitty Genovese, who was murdered, and there were about 40 neighbors that heard her crying out and that basically knew what was happening, and none of them actually did anything about it. So then John M. Darley, he thought, well, I really want to figure this out, so he did a couple of experiments. He basically simulated an accident and then varied how many people were watching, and then he measured how long would it take them to help. And this effect was actually found quite often, and it's been discussed a lot because it's pretty scary for everyone. But there's a lot of different results. So some studies found this and some studies didn't. And what are we doing? So first, let's look at it more exactly. Sometimes when studies look like they're opposite, there's just differences in the design that explain the results. The differences sometimes only seem opposite. For example, sometimes the samples are different. If you use children versus adults, it's possible that there isn't one study that's wrong, but instead kids and adults are just different. Or you can look at the operationalization. So how did it look? Were there more trial people or like people that were not in on the experiment? Or was only one person not in on the experiment and everyone else was in? This can be a difference. So what can we actually do? We can do a meta-analysis or a moderator analysis. These are analyses that basically try to find out, does it make a difference if it's children or adults? About meta-analysis now. These are basically summaries of more than one study in a journal article. Now, usually the author of this meta-analysis reads a lot of studies and tries to read all of the studies to a specific topic in between a time frame. And then he or she will put them in an article, in a journal paper. And then he will also describe the differences and try to calculate the power of effects. So these power of effects is basically trying to say how much are these two samples actually different. So these power of effects are basically a measure of how large an effect is, and they're standardized, so they can be compared between different studies. If I look at the mean, then one person might have used a different scale, so I might not be able to compare them, but I can always compare the effect size. One example of that is Cohen's d, and there's kind of a rule of thumb. So a small thumb would be 0.2, a medium effect would be like 0.5, and starting at 0.8, we would basically talk about a large effect size.
So, and if you look at the effect size, then you see, or you better understand how impactful the influence actually is, or how you could better understand what kind of question was asked. And I found a meta-analysis of this bystander effect, and you see that this is actually quite a lot offers, because these literature reviews are very take up a lot of work, and you're encouraged to look into this study because it's actually very interesting, because they also talk about contradictions and make it more easier to understand what the results actually mean. Then there are also reviews, which are also papers that also try to summarize the current knowledge or the current theories and hypotheses in a research area. And usually it's from researchers that work in that field. And they also try to talk about contradictions based on the knowledge that the authors have. And people try to also explain why there are contradictions in different studies in these reviews. And these are pieces of advice that I give you to basically better judge scientific results and scientific publications. And in the end, I would like to talk about what kind of problems the science or the scientists have. And I don't want to show you just the positive side of science, because there are more problems in science than shown here, than these three problems that I'm going to talk about. But these are very important. So first of all, I want to talk about p-hacking, the replication crisis, and the publication bias. So what is p-hacking? It means that you manipulate your data to obtain the desired result. So the aim is that you decrease the p-value below 5% to obtain significant results, and so that you obtain a significant result. And this way you still basically trick the test to still say, okay, what you found out is statistically significant. And the bad thing is this is really hard to detect for other people, and only very few authors publish their raw data. And even then, if you have the raw data, it's not always possible to replicate all the work that people have done to obtain the results. And there are different approaches to deal with this. One is replication studies. For instance, I look at one study and I try to replicate it and see if I get the same results, which of course is not always. And this way you can basically reveal p-value hacking. But even if you find something different, it might not be intentional that the author has done anything bad. It might have been that there's a mistake, and you have to contact the original author and talk about why you get different results. And this is just an approach. This does not. So these replication studies, they're just an approach. They do not solve the problem itself. And then there's also this replication crisis, which is kind of strange because I just talked about replication as a method to basically combat p-value hacking. But there was an actual crisis in the field of psychology that a lot of scientific studies in the field of psychology, and some of them were very important and well recognized, could not be reproduced by others. And what are the approaches to deal with this? And the only real strategy is to have a better plan for the study to reduce the number of potential bad influences and do a thorough planning in advance. And sometimes it also makes sense to change the significance threshold. So I talked about having a threshold of 5%, of 1%, but sometimes it makes sense to reduce it even lower to make it less likely to get a false positive. But even this problem is still not resolved or solved. The last problem I want to talk about is publication bias. And the problem is that significance results tend to be more published than non-significant results. So if you don't find anything new or anything significant, it's unlikely that papers will be able to publish in journals. And if you basically have this bias of most of the publications that only show positive results, then you can get a different impression on what is happening in the field. If you knew more about okay, so another approach is meta-analysis. So you do research on existing studies and try to do corrections on the calculations to account for different factors, including potentially non-published studies that had no results and no significant results. And when I create meta-analysis, I also call different authors and different researchers who might have studies on the topic but that were not published. And the more I do this and the more responses I get, the better I can assess and estimate how many non-reported effects there are, how many non-significant results have been observed that did not make it into a publication. And still, this problem is not resolved. Now, there are, of course, I hope that I have answered the questions further. So the last couple of questions answered, but still the one big question remains: can we trust clinical studies? And the conclusion is that, yeah, somewhat you can do that, but it depends. So different studies have different levels of quality, and it's very important that you assess the study quality yourself. And that does not mean that everyone should be a scientist, but it's worthwhile to not only use the summary from popular science articles if you want to use this in a conversation, but it's also reasonable to really go back to the source and try to look at the original publications and try to get an idea of your own by going to the original sources. And it's really, really important that you understand probabilities. And that's why I included this method part in the beginning. So, because many people say, okay, a study found out that something is like this, so it must be true. But this is a common misconception because in the end, this is all probabilities. And this is all about being certain about something. So, and there are, basically no study is like 100% certain. And then, of course, there are meta-analysis that can basically give you a better overview over what has been published, which also applies to the reviews. And, of course, we still have these open problems in science and scientific work. And this is something that you should not disregard or ignore. And, well, the conclusion is really, like said in the beginning, science, as it is right now, is the best what we have right now, but it's not perfect, and it's important to stay critical. And right now it is. So studies are the best thing we have, but we should still be critical.
Kleiner Kommentar vielleicht zum Abschluss.
Small comment, maybe. Towards the end, even also looking at locked up science, all the studies that I cited here are freely available, open on the internet, and you can actually watch them read them if you want.
Okay, thank you very much. Now we have time for questions. Please go to the microphones and I will try to coordinate the questions. But first of all, let's ask the internet. Where is the internet? Nothing from the internet.
Ja, hallo.
Now let's start here. Hi.
Irrtumswahrscheinlichkeit.
So,
Du hast gesagt, das ist mal auf 1%, mal auf 5%
Regarding
festgesetzt.
the
In der
error
vorgestellten Studie
probability.
habt ihr 3% gesagt. Mir ist
Now,
immer noch
you
nicht ganz
said
klar, wo der Wert denn nun
1%,
eigentlich herkommt.
sometimes it's
Macht ihr die
5%, the
Studien,
study
macht
had
eure Statistiken,
3%.
eure Wahrscheinlichkeiten,
My
Berechnungen und am
question
Ende
is,
guckt jemand
where
auf
does
und
this
sagt,
value come from?
jetzt haben wir hier ein P
Are you doing the
0,4,
study and someone
wir
at the
wollten
end
aber
looks at it
0,3,
and
also
says,
sind wir nicht,
oh, we have a
0,03, also sind wir nicht
p-value of
signifikant. Oder sagen wir,
0.3,
okay, mit 5 kommen wir auch durch, dann
or
haben wir jetzt,
0.05, so we're not
4%,
significant?
also sind wir signifikant.
Or
Oder landen wir am Ende bei P-Hacking und sagen,
Are
okay,
you
wo
actually
muss ich
doing
hin, damit ich
p-hacking?
signifikant bin,
So
auch
where
wenn
do
es
I need to go
20% sind. Wo
become
kommt das P
significant?
her?
Where does the P come from?
Okay, so I didn't explain this exactly enough. It's important that before doing the study, on which significance level do you want to work. Do I want to achieve 5%? Do I want to achieve 1%? And then this is my aim. And then I use the statistical methods and I get a value. And this might be like 3%. And if I say I want to be below 5% and I observe 3%, then yeah, everything is fine. I have a significant result. And if I had said 1% and I observe 3%, then, well, unfortunately it's not significant. And that's exactly what I say. If you set higher aims, and that means lower significance thresholds, then you can be more confident.
This
doesn't really answer my question, because where does the p-value come from? Is it dependent on the statistics? Well, yeah, exactly.
Exactly. This is what you calculate. You compare the one variance with the other, and you get one value, and you see, and you look up in a table if that value is significant or not. Unfortunately, this is too complicated to explain in detail how the calculations are being done. I recommend that you look into a statistical handbook to see how these calculations are being done.
Okay, so we'll continue with Mike 4.
Is it conceivable that the different parts of a study is being distributed across several people, so that you have a meta-study within one study, and so that some people just do one part of the work and other people do other parts of the work?
That's possible, and that's happening sometimes. So most of the time, it's not the researcher himself that is actually doing the study with the trial persons. Instead of it's the assistants, and also you can give it to different people to do the statistical analysis. You could probably do that, and I've seen it often that you ask someone to check your results. And I'm guessing your idea would be possible, but it might be a lot of work.
Ja, danke für den sehr übersichtlichen Vortrag. Ich finde, ein weiteres Problem ist, dass Menschen, die außerhalb der Wissenschaft stehen oder außerhalb der Fachdisziplin, die Ergebnisse von Studien nicht direkt aus den Studien bekommen. Also sie lesen nicht die Papers, sondern die lesen im Internet oder in einer Zeitung. Das haben Journalisten geschrieben. Die Journalisten wiederum haben ihre Informationen auch nicht aus der Studie, sondern die haben das von der Marketingabteilung der Universität. Und da habe ich haarsträubende Dinge auch von großen bekannten Universitäten gesehen, dass die Marketingabteilungen dann die Studien komplett falsch darstellen, also komplett übertreiben, was die Effekte und so weiter angeht.
Yeah, that was more or less sort of my approach to encourage the people to look at the original studies and to look at them themselves, even though many of them are kind of off-putting to many people.
Gibt es die Möglichkeit, irgendwie so Details zur Studienplanung im Vorfeld schon irgendwie bei einer dritten?
Are there possibilities to look at details of the study planning and to basically publish them before you do your study?
Wir haben uns eigentlich P gleich 5
so that
als,
you can't
gleich 1 als, also 1%
basically a commitment by researchers, because we had set P at 0.1, but we actually got 0.3.
Yes, it's possible, and it's actually gaining more adoptions, so that a lot of papers actually say a lot of journals say, okay, before doing the study, you actually have to send in an abstract, and then you have to make sure in advance that you commit to a specific plan and to a specific threshold. And I think this is a very reasonable thing, but it's not done enough at the moment.
Die Eins, bitte.
Hi. Ich will noch mal kurz auf die Signifikanzniveaus eingehen. Und das Erreichen der Signifikanzniveaus an sich ist ja kein Merkmal für Qualität einer Studie, richtig? Sondern nur die Interpretation dessen.
Is not really something that shows quality, but instead it's just a manifestation.
Yes, that is correct. So if the results are significant, it doesn't tell you if the study is good or bad or qualitative of high quality. And but there are also studies that are good because they so they are good despite finding no significant results.
Ja, danke schön.
Thank you.
Erstmal vielen Dank für den schönen Vortrag.
Thank you for this nice talk.
Boah, Latenz ist ja echt fies.
Okay.
Ich hätte eine Nachfrage zum Publication Bias. Wir haben in vielen Wissenschaften das Problem, dass viel veröffentlicht werden muss, um überhaupt an eine Stelle ranzukommen. Wie wird da speziell in der Philosophie, wollte ich schon sagen, in der Psychologie mit umgegangen, wenn schon ein Problem mit Publication Bias besteht?
Yeah, how do people deal with it? Well, you still need to publish to have a good scientific career. And I don't know of any good approach to deal with this. It's really, unfortunately, that scientific studies that find something significant are more likely to be published. If I knew a solution to this problem, I would be very happy. I'm sorry that I can't offer a solution.
Vielen Dank für den schönen Überblick.
Thank you for this nice overview.
Für mich persönlich war der letzte Teil am interessantesten eigentlich.
The
und
last
ich wollte
part
fragen, ob
was
du nochmal
the
darauf
most
eingehen kannst,
interesting.
wie diese drei Probleme eigentlich alle zusammenhängen, weil das wirkt ja jetzt so, als wären das irgendwie so drei Dinge, die man im Hinterkopf halten sollte, aber eigentlich irgendwie auch gar nicht so schlimm sind, man weiß, dass sie gibt. Aber die haben ja einen riesigen Einfluss darauf, wie alles in der Wissenschaft aussieht und die hängen ja auch miteinander zusammen und auch gerade dieser Impact, der ist ja irgendwie auch ein Auslöser für diese Probleme, die Fixierung darauf.
Yes. So, of course, there is a connection between these three problems. P-hacking can be reduced by replication. And then, of course, replications, there are problems. And of course, we can talk for a long time about this. And I can also recommend the other talks about replication bias that are currently running or currently being presented. But I didn't understand what I should say to the publication bias.
Wie zum Beispiel P-Hacking eben mit dem Bias zusammenhängt. Also
how
gerade
is
dadurch, dass man sich auf
P-hacking
diese
related to the
Studien
publication bias?
fokussiert, kommt es eben zu P-Hacking und
So
das mit
because
dem Impact-Factor zusammen.
You have to publish studies, you do P-hacking.
Absolutely, that already answers the questions. If only studies are being published that have a significant effect, then of course scientists are much more incentivized to change the data and to induce p-hacking, to create p-hacking, to have publications. But the problem is that publication bias, to resolve this, is really, really difficult, because we as scientists, because as a scientist we're also not that interested in reading in journals that are so many things that don't have any significant relationship.
It's now 12:23. The internet woke up and has a question. So how do you deal with errors that you can only see after you've published it as an author?
So in the ideal case, you should state that something was wrong and, of course, do another follow-up study to see if this incorrect measurement or whatever has actually a negative effect on the results. So far, I haven't experienced this myself, and I haven't seen this for other people.
Ja, danke auch von mir nochmal für den Vortrag. Ich würde noch mal kurz auf die Herausforderungen eingehen. Du hast da ganz zum Schluss gesagt, es fehlen die Daten und Replikationen können teilweise nicht erstellt werden. Gibt es da Ansätze, dass zum Beispiel Journals existieren, die die Veröffentlichung der Daten erfordern und die vielleicht auch erfordern, dass eine Studie nicht nur einmal durchgeführt wird, bevor sie veröffentlicht wird, sondern dass sie zweimal durchgeführt wird?
So I'm not aware of any requirements to do a certain studies twice, but there are some scientists who by themselves want to publish their data, and they publish the data in the internet, but I'm not aware of any journals that really require that the data has to be published. But my impression is really that it's the scientists who want to publish and who want to support science as a whole with publishing the data.
Hallo, ist die Tatsache, dass man gerne einen falschen Untersuchungsgegenstand angibt, schon mal aufgefallen? Kann man das irgendwie
have you seen that people like to basically offer a wrong topic? So you're actually
ja, wie du gesagt hast, zum Beispiel, dass man sagt, es geht um körperbehinderte Menschen, die mit dem Mund schreiben.
For example, it's about disabled people, but instead it's about
Weil
laughing.
man würde ja meinen, dass
for example,
mittlerweile sehr viele Leute auch denken, dass in der Psychologie, wenn du zu einer Studie gehst, das tatsächlich um was geht.
In psychology, that many people would think that you actually don't lie to them.
No, I don't think that there anything like, I mean, so these cover stories during the study, so you want to delude the study participants about what the study is actually about while the study is ongoing, but in the end you will tell them what the study is actually about, and it's also in some studies the researchers actually ask the people if they can guess what was actually tested, and if people realize what's actually going on, then it might be reasonable to leave these people out because their understanding of the tests can influence the results.
There's a question. Could you please say something about funding bias? So basically, who gets the funding and how it influences research?
Yeah, that's a big topic for research. Unfortunately, I cannot say so much simply because I was only at the university and I didn't have to deal with specific donors of money because my research so far has been completely funded by the government.
Ja, also meine Frage wäre, gibt es vielleicht sowas schon oder könnte man das nicht machen? Ein Bewertungssystem für Studien, so nach dem Motto, dass für alle transparent ist, okay, mit dieser Studie haben sich schon diese und jenen Wissenschaftler beschäftigt und die vergeben zum Beispiel in Kategorien irgendwie Noten oder so und am Ende gibt es dann ein System, wo man sagen kann, okay, also die Studie ist zumindest so belastbar, dass schon viele Leute sich damit beschäftigt haben und attestieren konnten, das ist zumindest handwerklich korrekt gemacht
and seen that it was done right.
Yes, there is something, and you can look at the citation count. If a lot of people have cited the study, then hopefully everyone has read the study, and you can somehow conclude that the study is probably good. But so if you would establish a rating system, then how would you agree on what kind of ratings to give to papers? It's like very subjective, and so of course we have the peer review and it goes into the general direction, but I don't think that a rating system is something that you can objectively set up.
And this is the last question now?
Kurze Nachfrage zum Thema der Metastudien.
Regarding meta-studies.
Wie viele Studien idealerweise zusammengefasst sein
so, how many studies should you
Also ich frage deshalb, man stolpert teilweise über hunderte von Teilstudien in Metastudien. Ich weiß nicht, sollten da die Alarmglocken angehen oder ist das eher Qualitätsmerkmal?
Is that good or bad?
It depends on the field. If the research field is relatively new, then of course there are not many studies and you cannot use many studies for your meta-studies. But the bystander effect is something that has been researched a lot. Then of course I expect a lot of studies to be part of the meta-study. So I don't think there's a general guideline that you can use to say how many studies there should be. I would rather focus on how did they select the studies for the meta-study. Did they call the authors? What kind of search terms did they use? And in these meta-analysis, they usually state this, what kind of strategy they use to find studies so that I can see for myself or I can assess for myself if they actually used a valid strategy or a thorough strategy to find everything that I deem relevant.
Okay, and now this